Hello, today, or right now, I'm going to take a look at some of the stuff that we had from Friday, solving logarithmic equations. And when we're solving log equations, we take similar approaches as we do with exponents, where if we have exponents of the same base, we can combine them into a single exponential expression and use the properties of exponents. When we have logarithmic expressions, we can combine using properties of logarithms and take advantage of other properties and switching between exponential and log formats to help us solve the equations. Two strategies that we have that we're going to be using. We know that if log some base of x equals log some base of y, then that implies that the arguments, the values inside the logarithms, are in fact equal. We've got a function here applied to x, it's the same function applied to y. That means that the insides, the arguments, have to be equal. So that's the first thing that we're going to take advantage of. The second is sometimes it helps to switch between exponential and logarithmic forms. So I'm going to take a look at a few problems off of the practice that we had, try those out. Hopefully that gives us enough examples to try them out more on our own. This first one here, I'm going to pull this up in MathType so I can see it and edit. At log 5x equals log 2x plus 9. Now, first thing, there is no index, no base listed below the 10, below the log. When that happens, we assume that it's log base 10, but it actually doesn't matter here. What we have is log base 10 of 5x equals log base 10 of 2x plus 9. Since we have log base 10 of an argument equals log base 10 of an argument, that means for us that the two arguments are equal. So we can set the insides of the log equal to one another. From here, it's just a matter of arithmetic steps. I'm going to subtract the 2x, giving us 3x equals 9. I'm going to divide by 3, giving us x equals 3. There we go. Second one. Now, there's a little bit more here. There's only one logarithm. It's log base 2. The base doesn't really matter for the most part. We're going to use that later on. Now, what I see is we've got these values outside the logarithms. I'm going to combine like terms. So the first thing I'm going to do is I'm going to add this negative 10 to the right side. And I happen to have negative 10 on the other side as well. Add 10, add 10. That's going to give us log base 2 of n plus 3 equals 0. Now for this, we can't say that an argument equals an argument because, well, there's no value, no logarithm over here. We do not have the log equals a log, so the two insides don't equal. From here, since we have only one log expression, we're going to switch back to exponential form. So we have, here's our base, this is our exponent, this is our answer. So in exponential form, this is going to be 2 to the 0 equals n plus 3. Now we've got something that we can evaluate. 2 to the 0 is 1, n plus 3. Subtract the 3, we have n equals negative 2. Going to move on to number 6, just as another example. Here we've got log base 2 of x plus log base 2 of 8 equals 2. We've got two logs on the left side, but we have a numerical value on the right side. With the two logs expressions, I'm going to combine those using properties of exponents. Now what I see here is that we have the same base, so we can combine these using our properties of exponents. We are adding the two logs. When we are adding the two logs, we want to condense these into a single logarithmic statement. So adding two logs, we multiply the arguments, the insides. Well, that's going to give us log base 2 of 8x. That's the argument inside our log, equals 2. Now, since we have a single log expression equals a numerical value, we can switch from log form to exponential form. This is our base, this is our exponent, this is the answer. So in exponential form, this is going to give us 2 squared equals 8x. That's 4 equals 8x. And we can divide to give us x equals 1/2. Last example I have for now, number 10. Now we've got ln. ln is natural log, that is log base e, the numerical value e, 2.718. Again, well, now we have 3 logarithms. What I'm going to do is I'm going to combine those on the left side since on the right we just have log 5, I'm going to leave that alone. In order to use that first property, all the way back, if we have a log equals a log, then two arguments equal, we need one log on the left side, one log on the right side of our equation. On the left, we've got ln x minus 3 subtract ln x minus 5. I'm going to use properties of logs here, such that when we are subtracting one log from another, it's actually dividing the arguments. So these can combine. This will give us x minus 3 over x minus 5 equals ln 5. At this stage, we have natural log of x minus 3 over x minus 5 equals natural log of 5. We have a log equals a log. Therefore, the arguments, the inside values, are equal to each other. So I can set x minus 3 over x minus 5 equals 5. I have a rational equation. I'm going to cross multiply. This is going to give us x minus 3 equals 5x minus 25. And it becomes an equation that we can use our arithmetic steps to solve rather easily. I'm going to add 25. I'm going to subtract x. And then I'm going to divide. And there we have it. So try it out. Let me know if you have any more questions or if you need any more examples done out.